Okay, and you should have this LED. This is short for L-Edit. L-Edit is an old software package that's been developed over the years to do circuit design. So in the old days, they used L-Edit for simple circuits and things like that. Now they have more sophisticated software, and L-Edit has also gotten more sophisticated. But we use L-Edit with MEMSPro. It's basically a two-part software package. Okay, so you guys hopefully will be able to launch it. Now there's two places you can do that. If it's in your toolbar, you can just click on it. Chances are it's not. So you'll have to go here and select all programs. And if you look through here and scroll down, you'll see something that says MEMSPro 8.3. Okay. When you click on that, you've got all of these options in here. Well, the only one we're going to use in this class is called MEMS-L-Edit. And that looks like a red box with an L. Can you guys see that okay? Yeah?
Yes.
Fantastic. So if you click on it, it'll launch. And I think Albert's gone through this once or twice if you guys haven't done it yet. So hopefully everything, you'll be able to get this far pretty easily. Once it comes up, you can adjust this window to fit the whole screen. You can see, hopefully you can see on your computer and on your projection screen little dots. That's a grid. And you can play with grid sizes, you know, and customize it. But you can play with the grid sizes and you can turn the snap on or off. So right now the grid snap is at 1 micron. You can see 1 micron here. And if you select this one, it's 3 microns. You can see it's snapping a little bit bigger steps. Can you guys see that?
Yes.
So these are bigger snaps. And this one is a 10. So you can snap every 10. And those are the big, you can see the big units there. So we're assuming these units are in microns. Okay, you can always change that later on. If we do some 3D printing, we might have to play with the scale a little bit on the output file so you can 3D print whatever you design. Okay, so if I leave it at 10, you can see these big snaps, and that makes life easier to draw things. So the first layer we usually draw when we're making something is poly 0. And that's your first layer that's on top of the substrate. Okay, we usually don't draw on nitride. So, and we don't draw on the substrate either. So poly 0 is our first one. So I'm just going to draw a big pad. And you'll find out, oh, that didn't work. Why not? Well, I'm on this pointy toolbar, this pointy selection mode, which just points at things. Okay, if I want to draw something, I've got to switch to drawing a different kind of element. So we'll pick the simplest one, which is drawing boxes. Okay, so now I've selected that. I'm going to select my layer again, and now it's highlighted. And you can click and drag your poly 0. Okay, so I just made a big poly 0 pad. So poly 0 doesn't move. It's stuck to the surface. Okay, it's doped so it's slightly conductive. And the reason we put poly 0 down is it acts as a ground plane. If you don't put poly 0 down and you just leave silicon nitride there, which is the layer underneath the poly 0, silicon nitride is an insulator, so any charges that are on the wafer are going to collect and not move. Well, if you get a charge on one layer and a charge on another layer, they can attract each other and they can stick. And then your moving parts don't move anymore. Remember, these are really, really small. Okay, so a static charge can mess you up. So we usually will put a poly 0 pad down and we'll actually, you know, ground it. Okay, so we might, you know, put a wire coming off of it, and these are really broad wires. And then we can ground it to different points on the chip, on the final chip product. And then that way, you know, all the stray charges that might be on the poly 0 can be drained away. Okay? But for the purposes of this exercise, this cantilever exercise, you don't need to draw those in unless you want to. All right, so now we got our first layer. Well, remember, a cantilever is a diving board. Okay, so I've got to draw my diving board. And the diving board has to be connected to the poly 0. So some people will draw the anchor first and then the diving board. Others will draw the diving board and then the anchor. It doesn't matter what order you draw things, but you got to end up with both. Okay, so let's go ahead and just draw the poly 1. I'm going to switch to another grid. Let's do snaps of 3. And then I'm going to draw my poly 1. Okay, so that's my diving board. So if I was done with that, I would have this poly 1 floating on top of the poly 0. And then when I go to remove the sacrificial oxide in between, it would float away because it's not grounded to anything. So I got to stick an anchor in there. So I'm still drawing boxes, which is fine, and I can go in and I can draw an anchor. And this is anchor 1. There is an anchor 2 as well, okay? But we won't talk about that on this assignment. We'll talk about anchor 2 later on the other assignment. And when you read through the manual at the different layers and their rules, you'll start to understand what the different anchors are for. Okay, so if I go in and I draw an anchor, and I've got a nice little anchor, and you might go, well, what the heck is an anchor? Well, this thing is a hole in the silicon dioxide between the poly 0 and the poly 1. And if you remember from the other lecture I did with the crayons, right? I call it my crayon lecture. We had to make that hole into the into the silicon dioxide. And we do that with the anchor 1 mask. So these are different mask layers you're drawing. We've got poly 0, anchor 1, dimple, poly 1, and it's nice because these are in order of the way they're deposited. So we start with the substrate, we add the poly 0, and then when we add the oxide and we drill a hole in it with the anchor 1 mask, etc. Okay, so now I've got the real basics of a cantilever, right? It's not going to float away. It's locked down to the ground. That's awesome. All right, and maybe that's all we need to do. Okay, so if that's all we need to do, we want to take a look at it. So I'm going to go and add this toolbar in here. And I've got a lecture or like a 10-minute video on how to find this toolbar if you lose it and how to bring it back in. I think once you save your first design, it'll remember that toolbar. I have to go to MEMS 8.3 because that's what's loaded on here. Then you go to MEMS libraries and you click on the MEMS physical.dll file and open that. Then it loads up and it remembered from the last time, but if it doesn't, you pick the MEMSPro palette, which is the first one, and hit run. And then you get this nice toolbar back. This is very handy. Now you can find these things in these other toolbars, but it's a pain. So I always tell students, go ahead and load this toolbar. You have a library of parts. So once you start doing more advanced designs, you can start to use the linear comb drive, library element, and the rotary motors and that kind of thing. But we won't do that today. We're just going to draw from by hand. But now I've drawn something and I want to see what it looks like. So I go to 3D Tools, okay, and I go set the 3D area. So I can pick any area I want to look at. So I'm going to look at this area here. Okay, now I didn't pick everything. I kind of cut it through the middle. And I did that for a reason, which will be self-explanatory in a minute. So once I set the area, I've got to tell the computer to actually make the model. So I say View 3D Model, and it's building it. If you watch this code flying by, you can see it's depositing and etching materials. So, and it goes all the way up through metal. There's a metal layer. Okay, so you can make things shiny. And then once you're done, you can close this log file. You can look at it if you want to, but it's kind of boring. And then you have your nice 3D image there. Okay, and you might say, well, what can I do with it? Well, with the scroll bar, I can zoom in on it. A little scroll knob on my mouse, right? Right in the middle, you have that scroll thingy. Okay, so scrolling, will make it go in and out. Well, let's say I want to rotate it. There's this orbit view, right? So it says switch to orbit view. If you click on it, now if I use my left button and hold it down on my mouse, I can rotate this thing, which comes in handy. And let's say I totally mess up and I'm lost. I can't find my way home. There's this drop down, so you can pick different views from the drop down. Okay, so that's a top down view. It's kind of boring. That's front view. No, here's an oblique view, which is probably the most useful when doing 3D stuff. And then you can do a side view, which is useful as well. So the side view will show you, hey, I've got my anchor here, so it's not going to float away. If I zoom in on this, and I'm trying to remember how to pan, the pan button somewhere. Let's zoom. There's pan. So, you click on the pan button, then you hold the left button, and you can move it up and down. Okay? So you can see, here's your substrate. This is your crystalline silicon wafer, the gray stuff. The blue stuff here is silicon nitride, typically. And you can look at the PolyMUMPS process and design manual, and it'll tell you what the order of these are. And this is your Poly 0. Poly 0 is a little thinner than the Poly 1. And we made a hole with anchor in the sacrificial oxide, which used to be in between here. You don't see it anymore because it processed it away. And you can see that, this hole was filled with the Poly 0 and you formed an anchor. So now this cantilever doesn't float away. Okay? If I take the anchor out and remodel this, which I can do, okay, let's go ahead and select. I just selected the little gray box. I think you can just go to Edit Cut and get rid of it. Now I'm going to go ahead and do another area. An area this time. Okay, and do the whole thing. So I set the 3D area, and now I'm going to view it and regenerate it. Okay, so it's going to regenerate that drawing. If I don't regenerate it, it'll just assume it's the same drawing from before. So now I regenerated it. Okay, I'm going to close this box. Go back to my orbit tool. And now you can tell there's no anchor. Okay, so did you guys get that?
Yes.
This is real handy. You can draw a little piece of your homework and then look at it in 3D and say, oh, I forgot something. It doesn't look right, and then play with it some more and look at it again. So I'm going to go ahead and throw that anchor back in there. Okay. Oops, I got to select my box and then I draw my anchor. I made it a little bit different this time. And I'm going to add something else. There's this, let's see, where is it? Hold 0, hold 1. I think hold 0, let's find out. Hold 0, I think, puts holes into the Poly 1. But I'm not sure. So I'm going to make a hole 0 because I don't remember, and I'm going to make a hole 1. Oh, that looks like it made it into the Poly. But if we're not sure, we can go ahead and do set 3D area. We're going to cross section it this time. I'm going to cut through the middle of it. And what do we click after we set the 3D area? View 3D model. And we got to regenerate. Okay, now you can imagine if you have a really complicated design and you pick the whole thing and do a 3D model, it may take a half an hour for you to build that model. Okay, so look at little bits and pieces of it first before you do that. Okay, so now let's close this out. I'm going to go ahead and click on the orbit tool. Oh, look, hold 0, put a hole in what? Poly 0. See that? And hole 1, put a hole in poly 1. So I can make holes in things. That's kind of cool. Now look what happens when I make a hole in poly 0. I get this weird effect in my poly 1, don't I? That's because the polycrystalline silicon is conformal. So it follows the shape. And I'll probably do an iPad cartoon on that and post that so you understand how conformal deposition works. Okay, but that's where that comes from. And if I make a big enough anchor, you can see the dimple in there because it's filling this hole up. So some of the material, goes down into the hole and leaves like a little divot on the top. So, if I'm layering something and I'm layering it into a hole, you'll see a divot going into it. It's kind of like snow falling, and if the snow is falling and there's a gap where the snow's trying to cover, you'll see a divot right on the surface of the snow. Just like if you leave something in your yard and it snows, you'll see a bump, right? So, deposition's kind of like snow falling. It builds things up, but then the top of the snow is bumpy depending on what's going on underneath. Okay, and that's called topography, right? You have a bumpy surface, which could be messy if you're making moving parts and they're bumpy. Okay. All right. So that's cool.
What about dimples? How would you have dimples?
Yeah, dimples. So we're going to make some dimples. I'll click on that. That's a good question. I'm going to go to a finer snap grid, and I'll make a dimple. Now I'll go to my 3D tools, set the 3D area again. Let's look at it this way. All right, then I'll go and do view model, and I repeat myself a lot, regenerate. So when you get in front of the machine, you'll start to remember some of this stuff. And hopefully you can open up your Moodle thing on the same computer as your software, and then you can go back and forth with the lectures and the how-tos and what you're doing. It'll take you a while to get used to it. Okay, so I just put a dimple in there, didn't I? And let me rotate this. Okay, can you see the dimple? So you might say, well, why would I want to put a dimple in something? Any ideas why I'd want to do that? It's a trick Sandia National Labs came up with. If you've got two really flat surfaces that are made out of the same stuff, even though they're different colors, it's the same stuff. This is polycrystalline silicon, the red one, and the yellow one's polycrystalline silicon. You have two materials that are the same and they're very close together, they can stick. And once they stick, it's really hard to get them apart again. And they actually have a really technical term for that. It's called stiction. Okay? That's an actual term, stiction. So, you got two materials that are the same and you bring them close together, all the van der Waals forces start to pull them in and it causes it to lock up. So you get this stiction thing. But if you go, yeah?
Use a dimple instead of an anchor?
No, you wouldn't put a dimple on top of an anchor. That violates some design rules.
No, I mean, can you use a dimple instead of using an anchor to
No, you can't. And the reason you can't is what's an anchor for? An anchor is to lock this thing down and anchor it to the previous layer so it doesn't float away. So if I use a dimple, there's no connection here. There's a gap. Okay? And the way they do that in the fabrication process is they'll put a hole in the photoresist and they'll only etch some of the way down. Some of the way down. And I'll have to do a cartoon lecture on that and show you guys what I'm talking about. So we need to do one on dimples and things. There may be one linked already in the unit from last year. But that's a really good question. So the dimple is actually there to keep things from sticking. That cantilever will come down and it'll hit on the dimple, but the dimple's so small, there's not enough force to let it stick. So it can come back up. Okay? If that dimple's not there, then that whole cantilever will come down and mesh, and it may not be able to become unstuck. Okay, and that's part of the release process. So I'll probably have a little lecture on that as well. I think once you're done, building the first cantilever and going through the manual and getting used to the terminology. See, I got lost. I'm going to find it again. Going through the terminology, then when I talk about how the design interfaces with the process of making it, it'll start to make a little more sense, okay? I know it's a lot, but this is kind of fun to actually draw something and 3D it and then move it around and look at it from all the different sides. And feel free to play, you can't break the software. So, if you get bored and you just want to see stuff, you can go to the library, right? Go to the library palette. Okay. Yeah, I think I have to get out of this view. Yeah, that's what it is. All right, and you can put a linear comb drive in there. Okay. So that's a motor. That's a linear comb drive, and you can see how those are made. Okay, and do things like that. So, basically for the cantilever, you want to put holes in the poly. You want to put an anchor. You want to use a dimple. That's the minimum. If you have a really big cantilever, you'll want to put a lot of holes in it, and the reason is you have to dissolve out that sacrificial layer that's in between the poly 0 and the poly 1 layer. Got to get rid of all that silicon dioxide, and the only way to do that is to make holes in these big structures that you're designing. These are thin structures over here, so you don't see any holes. Okay, I'm trying to think if they've got anything big. I think I've talked enough to be dangerous, and you guys can open up the software and draw some boxes. So get familiar with that. Well, the best thing to do now is just play with the software.